If you have any questions about any of the content in this video, just drop a comment down below and I'll get back to you as soon as possible. Enjoy the video. Okay, so the first question for trigonometry, specifically sine, cos and tan, is this triangle here, and we need to find the length of the side CB. Okay, so CB, let's first of all label where that is. It's this side here. So the first thing to always do is label our triangle. So opposite the right angle is our hypotenuse. We've then got opposite the angle in the question, which is 30 degrees, is our opposite side, and the remaining side is our adjacent. Okay, so if we want to work out this length here, we are given this one, and of course we know the angle. So we need to find a rule that uses the hypotenuse and the opposite, and that's going to be the sine rule. So the first thing to write down is that sine of our angle, so sine of theta, is equal to opposite over hypotenuse. And we'll then say that sine of our angle, which is 30, is equal to the opposite side, which is O, over the hypotenuse, which is 12. We can then multiply both sides of our equation by 12 to get 12 multiplied by sine 30. This is now equal to our opposite side, and we can therefore say our opposite side is going to be equal to, once I've done it on the calculator, we get 6. So 6 centimeters is the length of CB as our final answer. Alright, so for our next question, we've got this triangle here, and we've got two lengths, 9.5 and 6.4, and we need to calculate the size of angle POQ. So the first thing is, what actually is angle POQ? Well, we start at P, we go to O, and we end up at Q, and it's the angle in between. So it's this angle here, which we'll call theta for now. Okay, right, so let's now label our triangle. So let's change colour. Opposite the right angle, hypotenuse. Opposite the angle in the question, let's redo that arrow, is our opposite side, and the remaining side is our adjacent. Okay, so we've got A and O, so we need to use a rule that uses both of these, and that's going to be the tan rule. So we're going to say first of all that tan of theta is equal to the opposite over the adjacent, and then we can say that tan of theta is equal to our opposite, which is 6.4, over our adjacent, which is 9.5. Okay, and then the only thing we need to do now is do inverse tan. So we do tan, and then we say minus 1, this is the inverse tan, of 6.4 over 9.5, and this is equal to theta, and then we should get our answer when I've put this into the calculator. So we've got 6.4 over 9.5, and that should get us 33.96 degrees, and it says to 2 decimal places. Okay, so this ends up getting 33.9, 675 and so on, and then to 2 dp we end up with 33.97 degrees as our final answer. Just before we carry on with the video, I'd like to remind you that a full in-depth course is available for this topic over on my website. It includes everything you need, from the theory to complete worked examples, and even your own exam at the end to test yourself. Head on over to benthetutor.com to see all the courses I have available that guarantee your grades will go to the moon. Enjoy the rest of the video. Alright, so our next question is a bit harder because the diagram isn't just one triangle. You know, we've got a rectangle with 2 triangles. Anyway, let's see what the question actually wants. So we're told this is 42 degrees, that's 5 centimeters. We've got a right angle. Okay. What do we need to do? We need to find the length of the diagonal line AC. Okay, so let's just highlight that. So let's first of all label our triangle as we do for every question. So opposite the right angle is our hypotenuse, opposite the angle in the question is our opposite side, and the remaining side is our adjacent. Okay, so we need to find an equation that uses H and A, as we are given A and we want to find H. So that is going to be the cos rule. So we can say that cos of theta is equal to the adjacent over the hypotenuse, and substituting in our values, cos of 42 is equal to our adjacent, which is 5, over our hypotenuse, which is h. So we can rearrange to make h the subject. So we get h is equal to 5, and I'll just put the divide sign because we've only got one line left. So sorry, you couldn't see that. 5 and then divided by cos 42. Yep, and then we just put this into our calculator and we should get an answer. So 5 divided by cos of 42, and that gets us 6.728, and we want it to 2 decimal places, so 6.73 centimetres as our final answer for part A. Okay, let's move on to part B. So part B says, using your answer from part A, find the length of DC. Okay, so where's DC? DC is this here. Okay, so it says we need to use our answer from part A, but we don't actually need to. We could just use these two to find this side, but we'll use our answer anyway. So, well, there's a couple of ways we could do this. Let's first of all just label on 6.73. We could just use trigonometry with these two values. We could use trigonometry, including this value and one of these two. What else could we do? We could use Pythagoras' theorem, as we know the hypotenuse. So as this is a trigonometry video, we'll use trigonometry. So we'll this time use our answer, so hypotenuse, and we will also use the opposite side, as we need to find what this is. So a formula that uses O and H is going to be the sine rule. So we can say that sine of theta is equal to opposite over hypotenuse, and then sine of 42 is equal to opposite over 6.73. We then just need to rearrange, so we have 6.73 times by sine 42 is equal to our opposite, and then we put this into our calculator. Times by sine of 42, and that gets us 4.503. So to 2 decimal places we get 4.50 centimetres as our final answer for part B. Just before we get into the next question, if you'd like to get some one-on-one support, just drop me an email over at tutoring@benthetutor.com and we can arrange a session. Alright then, so this is going to be our last question. There's a part A and a part B, and it's the hardest question that we're going to do today. Right, so this diagram already looks a bit harder because we've got one triangle and then there's another triangle here. So let's see what the question actually wants. Find the length of ON. Okay, right, where's ON? Okay, it's this length here. So it already seems a bit harder because it's not the complete length of one side, it's part of the length of the bigger triangle. Okay, right, so let's first of all see what we're told. We are told that this is, oh, let's not do that. We are told that's 12 centimetres. So if we can work out this length, we can do 12 minus, we'll call this something, and then that will equal ON. And that something is going to be when we label our triangle. So let's label it now. So we've got our right angle, so this is the hypotenuse here. We've then got the angle in the question, so opposite this is the opposite side, and then we've got the adjacent. So minus O is going to get us ON. So we need to work out pretty much this length, and then just do this calculation at the end. Right, so to work out that length, we've got O, and we're given A, so that's going to be the tan rule. So let's first of all write down that tan of theta is equal to the opposite over the adjacent. Then tan of theta is equal to the opposite. Why have I done that again? I'm just repeating myself. So tan of 49.5 is equal to opposite over adjacent, where adjacent is 6.5 meters. We can rearrange then to get 6.5 multiplied by tan 49.5. And this will get us the length of the opposite side. So 6.5 multiplied by tan 49.5, that gets us 7.61, and then I'll use a few more decimal places as this isn't quite our final answer. And then all we need to do is what we said before, so we need to do our 12, take away this length, so 12, take away 7.6105, and then that gets us 4.3894, 8, 9 and 4. So to two decimal places, that is going to be 4.39, and the units are meters, aren't they? Yep, so that's the answer for part A. Just realised you couldn't see the bottom two lines, but there you go. If you need a minute to have a look at them, just pause the video. Okay, right, let's move on to part B. So part B, we need to find the size of angle OLN in the diagram. Right, where is that? Let's have a look. So OLN, okay, right, so it's this really small angle here. So we'll label this theta. Okay, right. So this is again a bit of a tricky question. So what I'm thinking is, if we can work out this big angle here, so 49.5 plus theta, we can then just take away 49.5 and we'll be fine. So what do we know? Well, we know that this is 12 centimeters, the entire length here, and we know this is 6.5, and this is our opposite side, this is our adjacent, so we're going to use the tan rule again. So let's just say it again. So tan theta is equal to opposite over adjacent. Substitute in our values, so we've got 12 and 6.5. So tan theta is equal to 12 over 6.5. And then to find theta, we just need to do theta is equal to the inverse tan. So tan to the minus 1 of 12 over 6.5. And that should get us our final answer. Oh, no it doesn't, not quite. So this will get us theta is equal to, let's work this out first. So tan to the minus 1, 12 over 6.5, okay, 61.557. Okay, and then we know the size of this angle, so we do our answer, take away 49.5. I'll just do it up here. So 61.557, take away 49.5, gets us our final answer, which is 12.057. And then it doesn't say how many decimal places, but part A was 2, so we'll do 2 again. So our final answer is 12.06 degrees. And there we go, that is our final answer for part B.